Hello, this video is going to be how to use Festo's Automation Suite to create an L5X file for our CPX-AP-A and our CPX-AP-I so you can import the I/O configuration into a Rockwell environment before you actually receive the hardware. So let's start with just a new project here. And what we're going to do is create both an APA centralized manifold and some API decentralized components. So let's start here with an AP device and go down to the interface module. This is also known as a communications adapter or a node. And since we want to use the Rockwell, our Ethernet IP, we want to choose the EP type. You can either double click or drop and drag from here. So first we have our node for our manifold. We'll go ahead and double click that one, and then it will install the plugin and then open up where we can actually configure our complete manifold. So here we are. We've got the communications adapter here. So the next step would be to choose what I/O we're going to have with that manifold. Currently just choosing the all would be fine, as there aren't that many modules available at this time. As the year goes by, we will release a lot more, so you may want to break it down to only digitals or only interface or things like that. But let's just start with all, because that's the whole list right now. So let's create a simple 16 digital input module. Let's put a I/O link module, and let's put an output module on there. So we've got 4 devices on there. So we have our manifold built. We can also then parameterize the manifold from here. So let's look at just the digital input module. Only really has one parameter. It's the debounce time for the sensors. We can change it from 3 milliseconds, either faster or slower, to these options. Just the one parameter is all that's available for that particular input module. Now, a module that you might want to have some more information on is the I/O link module. This one has a number of parameters that can be selected. The starting point here would be for the amount of I/O per channel that we're going to assign. Variant 8 stands for 8 bytes of data per channel. So there are 4 channels to the module, so that would be 16 bytes of data total. So what we can do is, if we knew we weren't going to need that much, we could say go down to 4, so we don't use as much data. It's using only the amount that you really are going to be, instead of wasting addresses. Also from here, if you knew how many ports you were going to start with, if you were going to use all 4 ports, or if you knew you're only going to use 1 port on there, you can start by changing the port mode from deactivated to IOL auto start. So let's just look if you're going to use the first 2. You can always turn these on from the Rockwell software as well, but in the parameterization, this is able to be done as well. So we configured 2 of our ports to be on in here. This is just the next 2 ports. Currently, we're going to deactivate them. So I'm doing parameterization on that. Let's say we're done at that point in time with the parameterization. Let's go back to our network now. So here's our CPX-AP-A manifold. That's our centralized portion. Now let's say we want to start putting a couple decentralized items on here. So let's go with a digital module here. Say we want to put another input module. So an 8 digital input, I'll double click this one to bring it out. So here we go. And let's say we want to put an analog module out here as well. So click the analog modules, and I'll double click again. There it is. And then finally, let's put a manifold on here. Let's use a VTUG. The 12 or the 24 on this refers to how many valve stations are on the manifold, and each station is considered to be a double solenoid. So a 12 valve manifold, but this could be 12 doubles is what we're looking at. Let's just take a 12, drag and drop him out there. So you'll notice in the APA portion, we have a 1, a 2, a 3, and a 4. What this is doing is this is counting up the modules. In the CPX-AP-A manifold itself, we can have up to 15 devices. This is up from the 10 that we could have on CPX standard. So it does allow you to have more devices on there. And then as we connect these other decentralized devices, CPX-AP-I units, from the communications port for the AP network, you'll notice we start counting up from number 4 to number 5, and then connecting these all up here to number 6, right there, and then from there to number 7. So we have in total of 7 modules in the entire network. This number can be up to 80 modules. That's 80 for the whole network. But for one manifold, it was 15. So we have our network created. So at this point in time, we're ready to export. So you go up to the little lines there, then come down to export. We want to bring it to a Rockwell environment. And then this is what the communications adapter was on there. You could have created multiple networks on that one screen, and there would be other communications adapters or nodes shown there. But for our system, we only had one network. So we'll take this one, and we're going to export it. It's going to ask you where you want to bring it to, and it's very important to remember where you're putting this because you're going to have to find it in a second here. So I'm going to call this CPX_AP_network, and I'm going to store it in my Automation Suite projects area. So I'm going to go ahead and save it there. It'll do some initializations, and then we'll get a message saying that the export is done. So there we are, it's finished. So at this point, we're pretty much finished with the Automation Suite. So what we're going to do now is bring in a generic Logix Designer or Studio Designer screen. What we're going to do here is just open that L5X file that we just exported. So we'll go here to open, and we're going to have to go to the Automation Suite where I put that. So having to remember where it was, going to open the CPX-AP network, and now it wants you to give it a title that you're going to save it as. So CPX-AP network sounds good enough for a title for a demonstration, but here's the real important part that a lot of people miss. You have to define what revision level you're using. I have Rev 32. You may have a newer Rev that you're working with, but this is missed a number of times, so that wanted to make sure I pointed that out to everybody. So we're going to now import the file, and it'll come up into our tree structure over here in just a second. So here's our Ethernet module, the CPX-AP-A that we were just working on. If I double click it here, we can see we have inputs, outputs, configuration data, and status inputs. And here's the sizes. We have our name, which can be changed, as well as the IP address, which can be changed on there. Now, one thing worth pointing out on here is on the main program, it also brings in a couple rungs, or actually 3 rungs. What this does is this changes the raw data into like useful data types for you. So for example, in a valve manifold where you've got coils, using booleans or bits is going to be the preferred way of controlling that. You wouldn't want to try and use, let's say, an integer value to turn on a valve or not. So using a boolean choice for that would be the easiest to use. But for, say, something like an analog value, using a bunch of booleans to try and create that just creates more programming work. So having something like, let's say, an integer value might be the best way to do that. So that's what these data types are doing for you. It's actually creating this for you. So let's look in the controller tags. Here is your raw data, your configuration, your input, output, and system. Again, looking right back here, input, output, configuration, and status, not system, I'm sorry, status. So this is the raw data, but then here you can see already we have some meaningful tags already assigned onto the inputs and outputs. Let's go ahead and open this up a little bit and take a little bigger look. So here, looking at a 16 digital input module, so these are all booleans. So going from 0 to 15 on there. And that was the first device on the AP-A manifold. The second device was that I/O link master. So here is the AP4IOL, which is an I/O link master. We defined it to be 4 bytes of data, so it's a cint with an array of 4 for each of the channels, 0, 1, 2, and 3. Then we move down to the next item here, which is still part of that I/O link module. This is status type data for it. And then we step out to the AP-I. Now we go to the decentralized, because the last module on the AP-A manifold was an output module, so that doesn't, of course, show up on the input side. So the first of the decentralized, we have again 8 bools for an 8 input module. And then coming after it, we defined an analog module. So instead of having a bool or even a cint, now we're using ints, because that would be the better data type to use with an analog module. The same can actually be seen here on the outputs. I'll run through a little quicker here so we don't spend too much time. But here's your I/O link master. Then here's your 8 digital output module that we had. And then we come down here to the valves. So a digital output module and a valve manifold are both bools. So it puts this in very useful data types for us. So how do we use this in our project? Well, we just go to the module here and we copy it. You could also drag and drop this, but since I've only got one screen to show, I'm going to do it this way. So now this is my working project. You can see I already have a lot more components filled into my device tree over here. So I just go to Ethernet and then paste it in there. So now here it is, that Ethernet module for the AP-A. If I open it up here, you see again that same amount of I/O. And then if I call up the controller tags, here you see that raw data, but you don't see that the condition data that was in the other file yet. How to get the those rungs in there, and then the modified data for easier use. We come back to that original project. We come into the main routine, and we can't just cut and paste here. We have to export these rungs, because there's more than just this these 3 rungs. There's data behind it. So I'm going to export the rungs. Again, making sure you know where you're putting it, so you're going to have to get it in a few moments. And we're just going to call it rungs. Rungs for network. Keeping it consistent there. So now we've exported it. Now we come over here to our main program again. We'll go back to the main program. And here we want to just right click and we want to import those rungs we just exported. Rungs for network. And bring them in. You will have to hit OK here, that all the programming that's behind it are brought in. So I'm just going to hit delete for this one empty line there. So now we have our rungs in our main routine here, and we go over to the controller tags. Now we see we have that same inputs and outputs and status here that we had before, where it's broken down into the useful data types for us. So we have our bools and our synths here, and then also on their output side here, you can see the synths here and some bools there. So they also have these data types and these descriptions here, so you can see where these points are being used and can start your programming before the hardware gets here. I hope this helps everyone. Thank you.